Hello students, welcome to my YouTube channel. In this video lecture, we are going to answer questions from 41 to 50. Let's start. Assuming a 5-dot display on either side of the ILS localizer. So it's a 5-dot display and they are talking about ILS localizer. What is the angular displacement of aircraft from the center line when the CDI is deflected 2 dots to the right? How many dots? 2 dots to the right. That means it's a 5 dot. So 3, 4. Okay. So 1, 2, 3, 4. So it is 2 dots. It's deflected 2 dots to the right. So 1 and 2. So over here. Okay. Now you have to remember this. You have to remember this. That on for a localizer column. So maximum deviation allowed is plus minus 2.5 degree. On a 5 dot indicator, every dot will be equal to 0.5 degree. Okay, maximum deviation is 2.5. So when you divide that 2.5 by 5, you will have every dot carrying a value of 0.5 degrees. Okay, so so now one dot equals to 0.5 degrees. So two dots will be equal to how many degrees? Two dots, 2 into 0.5 cross multiply. So it will be 1. Right? So it's a 1 degree angular displacement. That means your aircraft has deviated from the center line of this localizer by 1 degree to the left hand side. If the CDI needle is telling you to fly right, that means your aircraft has deviated left by 1 degree. So correct answer is option alpha, 1 degrees to the left. What is angular displacement of aircraft? So angular aircraft has been angularly displaced by 1 degrees to the left hand side. Next. Which of the following correctly describes ILS localizer radiation pattern? So, you know, ILS localizer aerial, which is situated on the opposite end of the runway, on the non-approach end of the runway, will transmit in the VHF band 108 megahertz, 112 megahertz. So, between these two frequencies, all the frequencies that have odd decimals will belong to ILS localizer. The even decimals frequencies will belong to the VOR. Okay. So now this VHF frequency, this main carrier frequency, is further amplitude modulated. 90 hertz, the left side of the radiation pattern will be amplitude modulated by 90 hertz and the right side by 150 hertz. So when your aircraft is correctly following the center line of the localizer, extended center line of the runway, it will receive both this 90 hertz and 150 hertz signals equally. Okay, we call that difference in depth modulation. The principle of operation is difference in depth modulation. Okay, so when it is receiving both the signals equally, the difference in depth modulation is zero. Let's say aircraft has deviated to the left hand side. Now when it gets deviated to the left hand side of the center line, it will receive more of 90 hertz signal and less 150 hertz signal. Right? So when that happens, the difference in depth modulation will not be zero. It will not be balanced. Okay? It will be more 90 hertz, less 150 hertz. So the CDI needle will move to the right hand side, telling aircraft to fly right to capture this needle or to capture this center line and then fly along the center line up to the runway. If your aircraft gets deviated to the right hand side of the center line somewhere here, it will receive more of 150 hertz signal. So your CDI needle will tell you to fly left, go left, capture the center line of the runway and then fly along it. Okay, so the difference in depth modulation is the principle of operation. So two overlapping lobes on the same VHF carrier frequency, two overlapping lobes on the same UHF frequency, two overlapping lobes on different radio carrier frequencies but the same modulation, a pencil beam comprising a series of smaller beams and carrying different modulation. So two overlapping lobes 90 Hz and 150 Hz on same VHF carrier frequency. Next. According to ICAO 8168 document, what is regarded as the maximum safe deviation below the glide path during ILS approaches? So, now the maximum deviation for a glide slope is plus minus 0.7 degree. That means you can deviate plus 0.7 degree above the glide slope or minus 0.7 degree below the glide slope. That is the maximum deviation. But that doesn't mean you have to follow that. That doesn't mean you have the permission to get deviated to the maximum limit of 0.7 above the slope, maximum deviation of 0.7 below the glide slope. It's not permitted. The maximum deviation that is permitted for in flying is half a scale deviation. So now full scale deviation is zero point 0.7. So half of that will be 0.35 degree. So when you have deviated 0.35 degree above the glide slope or 0.35 degree below the glide slope, okay, that is the maximum allowed. If you exceed that, you have to execute a missed approach. So maximum safe deviation on glide slope, deflection on glide slope equals to half of full scale deflection. If more than half, carry out a missed approach. Okay, so if this is your, let's say this is your CDI indicator. Okay, let's say it's a 5 dot indicator. So 1, 2, 3, and 4. 1, 2, 3, and 4. Okay, so maximum deviation allowed is, so full scale deviation is 5 dots up or 5 dots down. So maximum deflection that is allowed in flying is half of that, half scale deflection. That means half of 5 dots, which is 2.5. So 2.5 dots will be this or this. You can only get deviated between these two places. Okay, here and here, 2.5 dots up, 2.5 dots down. You cannot get deviated beyond that. Okay, so even though the maximum deviation here is 5 dots, 5 dots, you cannot try that. You cannot try that maximum limit. So, what is maximum safe deviation below the glide path? 1/4, that means 1/4. Full scale means full 1. 3/4 means 3/4. Half scale means half. So option is half a scale deflection is allowed. Question 44. Which of these markers has the highest audible frequency? Audible frequency means that frequency which you can hear at the highest pitch tone. So all marker beacons transmit on the VHF band of 75 MHz. This VHF band is further amplitude modulated differently for three different markers. For outer marker, it's 400 Hz and the pitch tone is low. For middle marker, it is modulated at 1300 Hz. The pitch tone is medium. For inner marker, it is amplitude modulated at a frequency of 3000 Hz and the pitch tone is high. So for which marker is the highest audible frequency? It's the inner marker. Okay. Next, which of the following is an ILS localizer frequency? So ILS localizer frequencies are VHF starting from 108 megahertz up to 112 megahertz. All frequencies that have odd decimals are localizer frequencies, odd decimals. So zero point 0.2 is an even decimal, so eliminate that. 0.1, yes, it's an odd decimal and it is between 108 and 112. So option B is the right answer. Option C, zero point 0.2 again. So even decimals are for VOR. So eliminate. Now this is odd decimal, zero point 0.1, but the frequency is 112.1. So 112.1 is more than 112, so we cannot consider this. So delta is also eliminated. 46. The heading rows of an HSI is frozen on 200. Lined up with the ILS of runway 25, the localizer will what? So, now the ILS localizer indications are independent of compass headings. Okay. So, even if the HSI indicator, horizontal situation indicator, shows a heading of 200 and your runway heading is 250, the localizer will still remain in the center position. Okay, the localizer needle will remain in the center, meaning you are established on the center line of the runway. Okay, so it won't get affected. Rate of descent is, what is the rate of descent if you want to maintain a 3.25 degree glide slope at a speed of 140 knots? So rate of descent equals to slope into speed into 101.3 divided by 60. So it is equal to 3.25 into 140 knots into 101.3 divided by 60. So 3.25 into 101.3 into 140 divided by 60 is equal to 768 feet per minute. Okay. So the closest option is option Charlie, 760 feet per minute. So you will select that. That's 48. You are flying a 3-degree glide slope and your ground speed decreases from 150 knots to a new value 120 knots. What will be the effect of this change in speed on your rate of descent? So formula is the change in rate of descent equals to 5 into change in ground speed. So 5 into what has happened, your ground speed has decreased from 150 to 120, means there has been a decrease of minus 30 knots, so minus 150 feet per minute. So the change in rate of descent is, you have to, as a pilot, you will have to add a little bit of engine power and slow down your rate of descent by 150 feet per minute. That means if you are descending at 600 feet per minute, you will descend at 600 minus 150, which is 450 feet per minute. You will come down at a slower rate. This is what it means. Next, what is the approximate angular coverage of a navigation signal for a 3-degree glide path out to a distance of 10 nautical miles? So this is the horizontal coverage, this is the vertical coverage. Okay. Now horizontally your glide slope extends up to a distance of 10 miles from the runway, 8 degree either side of the center line. Vertically, it has a lower limit and an upper limit. Now 3-degree glide path is the standard limit that you will follow. Now this 3-degree glide path have a lower limit and an upper limit. Now the lower limit is 0.45 times theta, where theta is equal to your glide angle. So 0.45 into 3 is 1.35. Upper limit is 1.75 theta, so 1.75 into 3, which is 5.25 degree. So lower limit is 1.35, upper limit is 5.25. So the correct answer is option delta, 1.35 degree above the horizontal, 5.25 degree above the horizontal, 8 degree each side of the center line. Next, what according to ICAO is the range of a locator? So the range of a locator, compass locator, which is installed in place of outer marker to enable your aircraft to fly inbound towards the localizer or towards the airport, has a range of 10 to 25 nautical miles, short range. Okay, simple. So this concludes the lecture. I hope you have understood all the 10 questions that I have answered in this video lecture. If you have any questions or doubts, let me know in the comment box. Thank you for your time.